Alright, so the gyrobot is essentially a nice little easy setup. You mount it onto a table, you plug it in, and then you flip the switch on, it's ready to go. It's supposed to be easy movable, and what it does, essentially you send it a Bluetooth signal, it turns on, it receives that Bluetooth signal through this communication, we send it through an app we have on our phone. Okay, that definitely does not. Which essentially allows us to just turn the signals on. So once we send the signal, it is able to do its own little thing and start. So essentially, and we can also kill the power too while we're at it. As you can see, we also power it off through the same signal. Now, essentially, it's made up of a few components. One, the Bluetooth chip, which essentially just receives the Bluetooth signal. We've also got a voltage step-down regulator, which just takes the 24 volts that the power supply provides and steps it down to 5, so this way all the other components, including the TiVo, can run. This is nothing more than a counter chip. It simply takes the information that the encoder at the end of the motor sends and uses that to determine what speed. We use that to determine how fast the motor is going and what direction it's moving in. Outside of that, we also have the IMU, and this guy is like one of the key components to this because this actually tells us what angle this shaft is actually at. It also is able to tell us the acceleration, but we really just wanted to use what angle, so this way we know what angle the arm's at. If you look back here, we also have the motor controller, which essentially takes a PWM signal that allows us to control how fast we want the motor to go, and also takes a directional signal to tell it which direction it needs to spin. And that is connected to, everything is actually connected to the TiVo, which is the motor controller that essentially drives this whole thing. He's the brains of the operation. So the TiVo has this block, which is essentially code and Simulink loaded onto it. It controls everything and tells it what to do based on what's going on. Here we've just got from the IMU the angles to tell us where the flywheel currently is in retrospect to where it needs to go. This just tells us the flywheel speed, so we can change it whenever we need to. And then those are fed in here to determine, this is for vertical maintenance. Essentially, there's filters and a bunch of other technical stuff, but essentially this just goes in and tells it how to maintain vertical once it swings up. So once it gets to about this area, vertical maintain will essentially kick in to give it different torques on the flywheel to essentially try and stabilize it up top. So, but until then, it actually it uses this functionality which tells it how to swing, how to perform the swinging up process. It's basic. It just takes the sign of the angle and tells it move in a certain direction based on the sign, because that'll tell it where it is. And then if we of course have the Bluetooth communication, and then these values, absolute values of the angles come in, so this way it actually knows what it's doing. Now this is actually the state machine. This is where all the fancy stuff takes place. That actually tells it when and how to jump from state to state. So essentially, we start off in the wait state. It's not doing anything. That's the power off. It gets the Bluetooth signal. It turns to go to the startup, or it turns actually to, well, startup process. Essentially, it needs to make sure that the IMU is sending the correct data, because the IMU has a little bit of lag to it. So once its proper data is there, it then starts up and essentially goes from state to state. Essentially, each of these states corresponds to a particular angle at which the flywheel is spinning. So the initial state, when it starts up, it's going to be down here, so it's going to have to actually jump start itself, kind of like you would with a car with the ignition switch. You got to turn it on first. So once it starts, it's going to start swinging. Once it gets to about over here, it's going to switch to the next state, which is essentially just lowering how fast the flywheel is going to go, so this way whenever it gets up to vertical, it doesn't overshoot so much. And essentially there's about 3 states in to lower it, lower and lower until it gets to vertical, and then it transitions to the vertical state, and then once again it just goes into maintaining vertical. Now it does also have set up so that if it does by any chance overshoot in any way, or just happens to fall outside, it will then immediately go back to trying to swing up, so this way, because it knows at that point it's dropped too far, it can't make it, so it tries to swing itself back up again. And once it catches, it goes back into maintaining vertical. And that's essentially how the entire thing operates.